Hello, this week I'm going to talk about the environmental impact of construction materials. When we use building materials, what do we care about? What materials we are going to use and why we use them, and what purpose of using that particular material? What do we consider when we make a decision? So here are 5 major questions. When we consider the types of materials, we have those kind of raw materials, natural ones from natural resources like stones, timber. Obviously, those need a process. When you process those raw materials into something useful in the building, we use energy. For example, you need to transport those stones, timbers into construction site. And if you turn earth into bricks, you need to bake and use energy. So not to mention those metals, the process actually use huge amount of energy, turn those raw materials through a number of complicated processing to metal and then building elements to be used directly into buildings. So the types. When we consider using the types, we have different considerations. And the considerations very often relate on our profession. For example, here I list 3. Structural, if you are a structural engineer, obviously durability, strength will be the major concern of using different materials. Now, if you are an architect, and then their looks, the texture, color can be the major concern. For building service engineers, then obviously we care about the thermal, sound, energy consumption for heating and the cooling and so on. So we have different focus because of our own profession. So therefore, when we make a decision, use what materials and how much we use, where to use, we need discussion. We need negotiation with other disciplines. Now, very often we consider why we use certain ones. We consider cost. When we consider cost, obviously we need some units variable to measure. Now, the most commonly used is capital cost. And then the second one will be the energy use. And that is very recently we found and it's being used as a unit, as a cost when we making decisions what material to use. And then the third one will be the carbon emission, because we have already realized that carbon emission is the major impact on the environment because of human activities, including making construction buildings and use buildings, and eventually knock down the buildings for some new buildings. So carbon emission, energy consumption, and capital are now costs considered in decision making for different types of materials used in a building. Although we know the purpose of using materials, although we know the costs to be calculated, then how do we judge? How do we make compromise between the disciplines, between the needs of those competitive requirements? We need some assessment methods, and that will be our topic today. So do we judge by purely the use of laborers, use of natural resources, or by energy, or by emission, or how much pollution is created, and many others? Do we have some kind of systematical, logical way to give us a guide to make assessment? Just like buying a mobile phone, What make us make a decision? The cost, the function, the design style, the budget, and so on. We certainly have a way to make a rational decision that convinces us we made a good decision. The aim of this talk is, number one, to raise the awareness of the association between construction materials. We know these materials, and we want to know how those materials relate to carbon emission. So that is first one, because carbon emission is a major concern in the society, and construction materials is one of the major issue in building audit. So that is part of this course. So that's why we introduce carbon emission as a new element to this course. Second one is we want to understand the major impact of use different materials. That is carbon emission. There are a number of different environmental impacts, but carbon emission is probably the most complex one. And on the other hand, it's quite easy to calculate, quantify. Third one is we want to introduce a basic concept about life cycle assessment for a building or a piece of building material. Obviously, we only talk about the fundamentals. It's kind of, the time scale, the duration, we make a judgment, like buying a mobile phone again. If you buy a mobile phone for 3 years of use, then the initial investment divided by 3 years. Every year, you just use a small amount of money. If you use just 1 year, then that cost become more expensive. So therefore, you can see the duration is one of the major elements making assessment. So we need to know this. The final one, obviously, is that the simplest method for the assessment is a quick, estimation, basically. Right, let's look at the effect of using materials on the environment. We start from what we're familiar with, the small scale. If we pass a construction site or a road construction, we know there are some impact. Number one, obviously, disruption to noise, to traffic, to life, to normal business, but to environment is something, for example, pollution, noise pollution, air pollution, water pollution, and so on. So these are quite obvious, and we know it happens to our daily life. Then how about large scale? We mentioned earlier, timber is the major raw material for construction. And then obviously large use of construction and large scale of construction projects leads to deforestation, depletion. And then if the forests changed, then obviously those animals, they will move away, so loss of animal habitat. Now, processing those materials into useful building materials, then cost of waste and the pollution and so on. So excavation of raw materials definitely has an impact on local ecosystem, and therefore you need to balance the needs and the impact well to make this kind of development sustainable. Finally, when a building finishes life cycle, then demolition will produce a large amount of building waste. How do you recycle them? How do you deposit them? Is another major impact to the environment. I mentioned earlier the concept of life cycle, the duration, as I said, 3 years as a lifetime of a mobile phone. Then if you use it longer, then obviously the cost becomes smaller. For a building, we consider from the raw material excavated from natural resources treat it, transport it into some products, and then move to the site, make into building, and the building operates to provide need for occupants over several years, and then end of life, knocked down, demolished, recycle the material, dump those waste, and so on. That completes the entire cycle. And throughout the entire cycle, we can say there are some stages, and each stage there are elements, there are process steps that involves energy consumption, user energy. For example, excavation, the machinery need to fuels to operate. Transportation cars need burn fuels to move the building materials. And the construction, those kind of cranes, lifts, all use energy. Knocking down explosive and so on and so forth, again, use materials. I use energy. And when you burn fuels turn into useful power, then there is carbon emission. So therefore, there is always energy connection with carbon until you found the renewable way to generate energy. So we can see the energy used in excavation, in manufacturing, in transportation, in processing, in demolition. So that is what energy consumes for. Now, if we look at the entire life cycle, we can divide it into 4 stages. The first one is producing building materials. So from excavate your raw materials on site and through transportation turn it into products manufacturing, then bring it into construction site through supply transportation and making it into a building, so that we have a final building as a product user can move in. And then there's a normal operation, provide lighting, heating, ventilation, heat and cooling, and so on and so forth. Transportation, like lifts and so on inside. Now all these facilities, all these kinds of services facilities need maintenance, and there's another cost. And repair, replacement, refurbishment, again, all use energy. Finally, when a building finishes use, then we knock it down to recycle those materials of those recyclable and dump those we don't need, or treat, make them easy to be digested by the nature's better nature. So all this again use energy. So we call this embodied energy when you making the material, bringing the material into a building. And then after use, you knock down, recycle, deposit, and so on. So the entire thing, we call it embodied energy. That is a cost. That's cost beyond the capital cost. We call this from cradle to gate and to grave. So if you consider the embodied energy from the raw material into a building, that is part we call it from cradle to gate. Now if you add another end of the life, the grave, so we call it the entire duration, we call the full life cycle, is from cradle to grave. Just we use analogy of a person's life. He was born and then trained to become a contributing member in a society, and that is a lot of education done. All right, and so there's between the cradle to gate. Gate is into the society to provide service, to making contribution to the society. Then when they died, funeral, crematised, use energy, and so on. So that's an analogy. Here are some examples. Different materials use different embodied carbon. So therefore, embodied energy, embodied carbon are all related to the building, from making the material into the building and then demolish, recycle. So the two parts summed together is called embodied. energy is energy used to make this one process complete. Now, those energy is produced by, for example, burning fossil fuels. So there's an association, there's a conversion rate from the energy needed to producing those energy needed produces some carbon emission. And different countries have different conversion rate. If those energies produced by renewables, then the conversion will be zero, so the carbon will be zero. So they are different units, they are not same. This is example. We have different materials on the first column, and they have definitely this measurable densities. And then if you give the thickness of this building elements, then there's a surface area. Very often we consider, for example, floor areas, right? Floor areas. If the floor slab is 12 millimeters, then multiply the surface area, you get the entire volume, and multiply the density, you get the weight of the material. So here we have per kilogram that material, how much megajoule energy needed to produce. For example, this internal wall partition, cellulose, you need 3.2 megajoules energy to produce 1 kilogram of this material. And if you compare this to another straw bale, that is natural material, you know, after harvest of wheats, you have the kind of straws, you can pack them together, make it into some kind of blocks. They are light and also use very little energy. So there's a very small embodied energy. If you look at, for example, glass actually has huge heat needed to turn into transparent or with some colors, right? So therefore, there's a very intensive energy inside. However, that material is recyclable, right? Anyway, glass has a higher embodied energy in it, right? So in UK, 1 kilowatt, 1 kilojoule energy need a certain amount of kilo carbon emission to produce. So therefore, you need to convert this embodied energy into embodied carbon. There are two units, as I said. The conversion, there are some conversions. Depends on how those energy is produced. Electricity, for example, in Scotland, produced by either a renewable and the other is fossil, natural gas and so on. So in that case, the conversion rate actually is very low. You need a very small amount of carbon to produce 1 kilojoule energy. And if you move to other countries where the power structure is predominantly produced by coal, that conversion rate would be very high. Okay. All right. So we have done about what do we use to assess the use of materials. We consider the impact to the environment, and how do we make the assessment is we use the indicators, which are embodied energy and embodied carbon. The time scale is full life cycle. Let's look at a few examples of demolition, the final stage when building finishes service. So end life, we have a number of reasons to demolish the building. The land can be made use for some other buildings, so we need to reclaim the land. Or before the building reaches the end of year, we found some structural fault. It's not safe to continue to use it. Or we found the function of this building doesn't meet the need of the modern time, so we knock them down. Or the building being damaged by natural disaster like earthquake or typhoon. And the pitiest is because of poor planning. Or initially you thought that would be a good idea to build a high-rise building, and after a few years after, or new policy comes in, you find, oh, that doesn't meet new need, the new need, you have to knock it down. And that is a poor decision making in planning. And we have seen a lot of this kind of poor human error made a huge environmental cost because of demolition. Give you some example. These are a few old buildings finished their service and then they knocked down, demolished for some other use. And this is a poor planning. There are 15 high-rise residential buildings, and they wouldn't be able to finish because of financial problems of the developers, and then nobody want to carry on because they believe that the designing wasn't good enough to meet the new needs. So eventually they knock them down, and you can estimate how much concrete used to build this before they into service and then knocked down, and how much environmental burden is created by those rubbish concrete waste. And the concrete has a very high embodied carbon, particularly in country like China. The energy is produced predominantly by coal. So now that raises another question. Why do we recycle? Obviously, recycle is to lower the project cost to some extent, and less expensive material use if we use recycled one. Now, the major one is for environmental consideration. We can reduce the environmental burden by produce less trash, and we also can reduce embodied energy. Recycle always use much less energy. As if we use glass as an example, glass from raw material into glass, there's high embodied energy, but recycle has very low embodied carbon, very similar to the aluminum. The aluminum is very low energy for recycle, and overall is to reduce the environmental impact. What kind of materials can be recycled? Here are some listed ones. Timbers, we are all very familiar. If you go to IKEA, you'll find that many of those kind of furniture use recycled timber. Steels, cast iron, aluminum, as said before, are all recyclable. And if you build a building for a short life cycle, then that would be the idea to use. If you go to Haymarket, you see now they are constructing a few new buildings, and very obvious is their steel structure, the frame, because they can recycle, they came those after the end of year of those buildings. Here are some examples using different recycled materials. The photo on the left actually is a straw bales. A farmhouse uses local harvest straws to process into big blocks with the timber frame to support the structure. The bales can provide good insulation for temperature, so it'll be very energy efficient when that is built. The photo on the right actually is a hempcrete. Is using straw mixed with concrete to make much stronger, durable, and fire resistance partitions for a wall. But it still doesn't support too much load, so therefore you still need a skeleton, a structural skeleton to support the building. Asphalt can be made into tiles for roofs, and reclaimed wood can, mix with some chemicals to make it strengthen, and it is a very, very good way to recycle. Now, we are very proud in our own university, Professor Mandira. She developed some way recycle waste into very attractive, high quality bricks. Even can come out in different colors, so make it very, very welcome by artists, and the clients also like this, because that's low environmental impact, and also use waste to reduce the environmental burden. So for high social responsible organizations, this can be a very good way to show their public image. Hempcrete blocks, as I said earlier, we have on-site poured concrete. We can also have this prefabricated blocks. So anyway, there are a wide range of different use. Steel structures, as I said earlier, is very popular. You can see almost all new buildings, no matter it's public buildings like schools or hotels or office buildings, or even residentials, are all built with light steel structures. Glass, aluminum are all very good materials to recycle. To conclude today, what we want you to remember is that when we make a decision of use different materials, we have an environmental concern. How do we consider a solution is environmental friendly? We consider one or two indicators: embodied energy or embodied carbon, and we consider those two indicators, calculate them over entire life cycle, from cradle to gate and then to grave. And we have a number of ways to calculate this. So that is what I would like you to take away. And when you consider the renovation of the library based on your audit, if you want to improve something, and then the new refurbishment, when you consider use of materials, you have something to rely on to persuade other people your solution is environmental friendly, it's sustainable. That is what we want. Okay, bye for now.